Good morning, students. Today I would like to explain how to design shaft. So, the numerical is the layout of transmission shaft carrying two pulleys B and C. Here, two pulleys are given B and C, supported on bearings A and D. Two bearings are given also. Is shown in figure. Power is supplied to the shaft by means of vertical belt on the pulley B, which is then transmitted to the pulley C carrying horizontal belt. The maximum tension in the belt on the pulley B is 2.5 kN. The angle of wrap for both the pulleys is 180 degree of, and the coefficient of friction is 0.24. The shaft is made of plain carbon steel. 30 C8 is the material for shaft, and yield strength is given as value 400 Newton per mm square, and the factor of safety is 3. Determine the shaft diameter on the basis of strength, means on the basis of maximum shear stress theory. So here we just draw the layout for the given condition for shaft carrying two pulleys, two bearings. Here pulleys are B and C, and bearings are A and D. On the shaft, pulleys and bearings are mounted. So again it is given that on pulley B vertical load is given, that is P1 P2 are the vertical loads, and on pulley C horizontal belt tensions are given, that is P3 and P4, and pulley diameters are given 500 mm and 250 mm respectively. So first step is let us write down the given data. Here given is SYT yield strength 400 Newton per mm square. Factor of safety is given as 3. Pulley diameters are given D1 500 mm. Then from pulley diameter we just calculate radius R1, that is D1 by 2, that is 250 mm. Then pulley diameter D2 is given as 250 mm. Then we let us find the radius R2 125 mm. And it is also given that for belt drive maximum tension P1 it is given as 2.5 kN, means 2500 Newton. Then coefficient of friction mu is given as 0.24. Also angle of wrap theta is given as 180 degree, that is pi. So let us solve or design a shaft. First step is found permissible shear stress. So how to find permissible shear stress? Tau is equal to having equation SSY, yield strength in shear, divided by factor of safety, and we know that yield strength in shear is 0.5 SYT upon factor of safety, and we got answer for permissible shear stress tau equal to 66.67 Newton per mm square. Then second step, how to find the values of tensions, that is P1, P2, P3, P4, and also torsional moment, that is MT. So let us assume that P1 is equal to 2.5 kilonewton or 2500 Newton. Then we know that limiting tension ratio for belt is P1 upon P2 equal to e raised to mu theta. E raised to, that is P1 upon P2 equal to e raised to mu is here 0.24 and theta is pi. So let us evaluate or calculate P1 by P2 ratio, that is equal to 2.125. So also we have value for P1 that we have already assumed 2500, and from this we can get the answer for tension P2. that is equal to 1176.47 Newton. Next step is to find the torque applied to the shaft by pulley B is given by, we know that torsional moment is nothing but P1 minus P2 into R1, that is torque applied to the shaft. By using this equation we just put the values of P1, P2 and R1. We get answer for empty torsional moment or torque is equal to 330,882.5 Newton mm. Similarly, the torque applied to the shaft by pulley C is given by also P3 minus P4 into RT is equal to MT. We know that radius R2 is 125 and we have already calculated the value of torque, that is torsional moment 330,882.5. From this we just assume this equation A, that is P3 minus P4 as 2647.06 Newton, and we have again limiting tension ratio P3 by P4 equal to e raised to mu theta, that is equal to 2.125. So from this we can get a value of P3 is equal to 2 in terms of P4, that is 2.125 P4. So put this equation B in equation A, you can get value of P4. So just by putting value of P B, that is P3 equal to 2.125 P4 into equation A, we can get the value of P4 or answer of P4 as equal to 2352.94 Newton. Again put this equation C in equation B, we can get answer for P3, that is equal to 5000 Newton. Next step is the torque applied to the shaft is given by, that is equal to MT. We know that P3 minus P4 into R2. We just here put the values of P3, P4 and R2 and we can get the torque applied to the shaft MT equal to 330,882.5 Newton meters. Then next step is total tension. We can find the total tension P1 plus P2. We know that we already assume value of P1 2500 plus we can get answer for P2 1176.47 and the total tension applied on pulley B is nothing but 3676.47 Newton, and that is for P3 plus P4 means addition of total tension for pulley C is nothing but addition of P3 plus P4, that is nothing but 5000 plus 2352.94, that is equal to 7352.94 Newton. This is nothing but total tension applied on pulley C. The next step is to find bending moment on shaft. Before finding bending moment of shaft, we can find out the vertical and horizontal forces on pulleys. So here find the reactions and maximum bending moment using vertical loading. VLD is nothing but vertical loading diagram and HLD means what? Horizontal loading diagram. So let us first consider vertical loading diagram. Here in this vertical loading diagram, A, B, C, D, for A and D, on A and D bearings are mounted and on B and C pulleys are mounted. So we have already calculated the total tension on pulley B and total tension on pulley C. So it is clear that from the layout that total here we consider a vertical loading diagram on pulley B. Here we it is given that total tension on pulley B is vertical applied, that is P1 plus P2. And here our task is to find the reactions and bending moment. Our task is to find RAV and RDV, that is reactions on point A and point D. So next, how to find reactions? Just take the bending moment at point A. Now to consider, by taking bending moment at point A, clockwise positive, anti-clockwise negative. So just taking bending moment at point A, we have one total tension, that is force 3676.47 into perpendicular distance between point P and A. Here it is 200, that is clockwise, minus 5 minus because RDV force is acting anti-clockwise, that's why it is minus RDV into perpendicular distance between point A and D is 1000, that is 200 plus 600 plus 200 is nothing but 1000. So just evaluate this equation, we can get reactions at point D RDV equal to, that is 735.294 Newton. Similarly, apply condition, that is summation FV, summation of all vertical forces is equal to 0. Again use condition that when forces goes upward use positive, when forces goes downward and take that force as a negative. So let us take summation FV, that is equal to 0. Summation FV means vertical forces. We have to only consider here vertical forces. Here vertical forces are RAV, then total tension P1 plus P2 and RDV. So RAV plus RAV, because we take RAV as positive because it goes upwards, plus RDV, that is 735.294 minus, why minus? Because this P1 plus P2 force goes downwards, that's why we take this force as a minus. So from this, by evaluating this equation, we can get the reaction RAV as 2941.18 newtons. So up till now we can find the reactions at point A and at point D, that is RAV and RDV. The next step is to find vertical loading or vertical bending moment at point B and at point C. So bending moment at point A and at point D is 0 because these are the two end points. At end points bending moment is always 0. So how to find bending moment? Find bending moment at point B means MBV at point B, that is vertical bending moment. How to find vertical bending moment at point B? That is RAV into perpendicular distance, that is again here we consider left side forces at the clockwise. So here MBV equal to RAV into 200, that is RAV, we have already calculated the value of RAV. Then from this we get a value for MBV, that is equal to, MBV means bending moment at point B, vertical bending moment, that is equal to 588236 Newton meter. Or in another way we can find same by considering right side forces, that is anti-clockwise, means right side forces means right to the B, that is MBV equal to RDV. Here right side force is RDV, it goes again anti-clockwise, right side force anti-clockwise, here you take as it is as positive. If you take a left side force clockwise, then it is again positive. So we can get answer MBV, that is bending moment at point B, vertical bending moment is equal to 588236 Newton meter. Answer should be same for whether we can take either left side force or right side force of a given point, and bending moment at point C, that is again we take left side forces at point C. At point C, the left forces are RAV and that total force P1 plus P2. So that is equal to RAV into 800, that is clockwise, minus 36, minus because it is anti-clockwise. Here left side forces we can take clockwise as a positive and anti-clockwise as a negative. Minus 3676.47 into perpendicular distance. Perpendicular distance here it is between point C and that is nothing but vertical force P1 plus P2 is 600. So just calculate these equations, we can get the answer MCV equal to 147062 Newton meter, or we can take MCV equal to 735.294 into 200, that is right side force. We know that for right side force anti-clockwise, for anti-clockwise direction we can take it as positive. So we can get same answer for right side force MCV equal to 147058. So uh, remaining calculations or remaining numerical we can discuss in next lectures. Thank you, students.